brave person who is by profession is a medical person, but he is among all the mathematicians. So it is my privilege to introduce Dr. Amitabh Dubey. So he is a senior professor in SMS Medical College and Apollo Hospitals in Jaipur. His academic qualification is MBBS and MD Physiology. He has published many of his works in the international and national journals. He has also been invited by Nature Medicine in the Translational Neuroscience Symposium at Lucerne, Switzerland in 2012 to present his germinal work on the dysfunctional mirror neurons in attention deficit hyperactivity disorder, ADHD, popularly known in the children's. Dr. Dubey has published books on cognitive science, neuroscience, sports, and exercise physiology. He's also worked as reviewer for many number of indexed and international journals. His research interest is biological signal processing and cognitive neuroscience, neural dynamics in health and disease, cardiorespiratory and sports physiology, with ongoing projects supported internally and externally. So now I invite Dr. Amitabh Dubey for his talk on the working model of human mind. Dr. Amitabh Dubey.
Thank you, sir. Thank you for your introduction. I'm sorry, मैंने भेजा नहीं था क्या? Oh, yeah. नहीं बेटा क्या कहाँ भेजूं? मेल कर दूं आपको? ईमेल आईडी क्या है? देखो यार, लेकिन आई होप दिस इज इन PDF. Anyway, in the meantime, he's trying to catch hold with the presentation. I prefer to move around and mix, and I try and prefer to interact with the audience, so that I learn, and we in that process the basic appreciation of the working of the human mind also gets evolved and gets further. Okay, sir? Send हो गया? वो format क्या है यार? PDF है? PDF है? ठीक है, thank you. So our journey basically is an arduous one. It began way back in 2003. Somebody said, about maths and biology. But incidentally, I had a passion for maths right from the very beginning, and I think I took up biology by force. So maths had been my passion right from school days. That's destiny, and that's how I'm here. So 2003 we started our journey in biological signal processing. Biological signal processing, and we have collaboration with BRC, MNIT Khaitan. Yeah. Oh, I'm sorry. वो नहीं क्या? नहीं, डेटा तो होना यार मेरे को। आगे PDF है? नहीं, PDF नहीं। सुनो, PDF नहीं है यार। ये PDF नहीं था वो, ये PDF लो अब। So 2003 we started our journey, and then we were basically initially medical sciences में जो है right आज से 30 years from ago we were talking in terms of exact values or values or parameters which were within a very narrow range. But then this thought process gave way. Yeah, mail ho gaya? Then this thought process gave way to a completely different paradigm, and that was when we started talking in terms of variability pattern. Variability of the human organ system physiology, all organ system physiology, organ systems physiology, they exhibit a trend in variability, and this variability has to have a particular range, a particular domain within which that organ system works. तो उस वेरिएबिलिटी पैटर्न को लेते हुए हमने 2003 से जो ईसीजी सिग्नल्स को जो है असेस करा था आगे। गुड, वेरी थैंक यू। ईसीजी सिग्नल्स को असेस करना शुरू करा। उसमें हमने वी केम अक्रॉस कि इट इज बेसिकली following it is not linear. It is not linear. It is basically non-linear. जो variability pattern है, it was non-linear in thank you madam. It was non-linear in nature. So non-linear के तहत then we came across Professor Paresh, and then we had another faculty from physics, Professor Dr. Manish Srimali. Right now he is in the Central University at Mayor, who was into non-linear dynamics. और उसके तहत 2005 में from ECD signals we started taking on working on the EG signals. EG signals में जो है पहली बार हमने देखा कि 2007 में कि they follow the principles of chaos. That is, there's basically a seeming order within the an order within the seeming disorder. ठीक है, तो उस पैटर्निंग को जो है again through the help of mathematics, there were some various transforms that were done. That we will try. Anybody interested, we can share. Professor Paresh has the details with that of the same. So इसको हमने जो document किया, and it was basically I mean, for the first time in North India we were the first to document that the human mind or neural dynamics follow the principles of chaos. और उसके तहत जो है हमने 2007 में हमको we were called by EFNS, that is European Federation of Neurological Sciences, जहाँ पर हमने फ्लोरेंस इटली में जो उसको रिप्रेजेंट किया था। उसी काम को आगे आगे लेते हुए 2012 में जो बात हुई थी कि we came across we were looking for pattern, pattern recognition. ED signals में जो है ED signals are basically signals which you acquire. आपके electrodes लगाते हैं scalp पर, ठीक है। दो प्रकार के हो सकते हैं scalp पे, that is non-invasive, और invasive जब होगा then you basically through a surgery आप अंदर implant करते हैं. That's a different story. We basically went in for a non-invasive EEG, this thing scalp EEG के तहत ये signals को acquire कर रहे थे, and we were looking for a pattern. तो उस pattern recognition के लिए जो है then we took help of mathematical modeling, जिसके तहत we could get close to a pattern which could be validated and which could be reproduced as well. तो पहली बार जो बच्चे जो होते हैं with special abilities, जिसको हम children with attention deficit hyperactivity disorder, उनमें हमने पाया कि they have a certain patterned EEG response, जिसको हमने पहली बार across the globe जो है रिपोर्ट किया था। तो जैसा बताया नेचर न्यूरोसाइंसेज way back in 2012 जो हमको बुलाया था, and उसका एक वो होता है कि it was basically given a name known as broken mirrors जो है। अब देखिए मैं आपसे भी बात कर रहा हूं और you are able to appreciate that I'm standing, I'm moving my hands, right? But आप लोग you are not doing that same thing. Human mind की जो working जो होती है उसमें आज से 20 years ago they said there were two mechanisms, the sensory mechanism, the mechanisms which receive signals, and the mechanisms which basically give an output signal which is specific and adequate to that sensorial signal. ठीक है, तो there were two mechanisms. Now ये two mechanisms were acting disparately. So I mean it was not a synthetic mechanism. तो उसमें एक जरूरत हुई an interfacial mechanism which basically creates an image, a neural signatorial image in the virtual stochastic phase space trajectory. Stochastic का मतलब पता है क्या? Stochastic the chaos का कोई नॉलेज है कोई यहाँ पर? हाँ, stochastic है ना, probabilistic. So basically it is that stochastic trajectorial phase space which the neural dynamics is basically etching onto the virtual human mind. दो चीजें, human brain is basically made up of various lobes, frontal, parietal, occipital, temporal, and the insular. The human mind is the stochastic trajectorial phase space representation of the working human brain. तो ये हमारा बेसिकली था जो this was about then we were talking about broken mirrors जो कि interfacial जो system जो होता है between sensory and the motor system. Now this mirror neuron, इसको हम बोलते हैं mirror neuron system. Now this mirror neuron system is responsible for formation of the image which needs to be formed in an algorithmic way, और वो उस स्टिमुलस को उस सेंसोरियल मैकेनिज्म के लिए एक एडिक्वेट इफेक्टिव रिस्पॉन्स को जनरेट करने के लिए the group of muscles to be recruited. ठीक है, मसल्स को हम डिवाइड करते हैं, जो फ्लेक्सोर जो कि who bend like this, extensors who bend like this, then there are various group of muscles जिसको हम abductors है. तो various group of muscles which are being recruited, उसकी neural image needs to be formed, और ये neural image form कर रही है by the species known as the mirror neuron system. अभी मैं आपसे बात कर रहा हूं and I'm moving my hands, but you are not able to do that. You are not doing it, but you can appreciate कि मैं क्या कर रहा हूं. तो वो appreciation जो है, जो आप समझ पा रहे हैं, that is because of the presence of a functional mirror neuron system, जिसको हम peekaboo neuron भी बोलते हैं. शुरू में जैसे when a child is born, so the child is basically learning from his or her mother. तो जैसे जैसे वो माँ इनिशियली वो साइन लैंग्वेज में बात करती है और उसको वो एप करता है, कॉपी करता है, इसलिए इसको हम पीकाबू न्यूरॉन्स भी बोलते हैं. जैसे जैसे माँ बोलते जाती है वैसे वैसे वो करते हैं. So this is the working model. Next please. The human mind. Now my mentor, my guru, who was Professor Padam Shri Professor Dr. Ashok Pangadia sir, basically he was responsible for what we could envisage and model the working of the human mind. Or next please. This was the neuronal soup through which we started. EG signals को जो है हम जो pattern recognition के लिए कर रहे थे. इसके पहले वाली दिखाइएगा please. इसके पहले वाली. That's how we came across the stochastic trajectorial phase space, which is the basic essence of the working of the human mind. Next please. Next नहीं back जा रहा, आगे. So ये basically 4-5 चीजें थी जिसमें हमने बताया कि भाई पहले शुरुआत में तो there was only sensorial neurons and the motor neurons. Then we came up with this idea of mirror neuron system. I mean, it was an interfacial neuronal system, और इसका नामांकन जो है nomenclature was done by Professor V.S. Ramachandran, and initial discovery इनकी way back in 1992 में Rizzolatti ने करी थी. He was from Italy. Professor V.S. Ramachandran is basically Nobel laureate status neuroscientist, stationed in UC San Diego, and he has worked a lot on children with special abilities or autistic spectrum disorder, जिसमें उन्होंने पाया था कि they have broken mirrors, or जिसको dysfunctional mirror neuron system बोलते हैं. They are not able to form the image, which is important, which is the essence of the flow of information from sensorial to motor mechanisms. अगर ये gateway या interface जो है if it is broken, then the information is not able to pass. ठीक है. Now this was till 2012. Now the other thing that we we started in investigating was language. जो भाषा जो है, language is the structured means of communication so evolved and which incidentally happens to be singular to humankind. Right? Humankind जो है as of this date, humankind has the most evolved means of communication, that is language. हो सकता है कि dolphin या whales कहें कि I mean they have their own, but I mean as can be documented, we have archives, we have libraries. क्योंकि language is most evolved in humans. Now language में जो है जो basic जो building block है language का, that is the letter. ठीक है, लेटर है, और लेटर के भी दो कंपोनेंट्स है, एक तो कंसोनेंट्स और वावल्स. Now, please give me, this is very interesting, consonants and vowels. Now, consonants and vowels, then when they are mixed, they give rise to the entity known as words. Now, words, there are meaningful words and there are nonsense words. Now, how a particular word becomes meaningful and how a particular word becomes nonsense, that again is big, where you know the rule of place and rule of semantics come into play. Place value जो कि numbers जो आपको देते हैं, numbers are responsible for the concept or evolution of the idea of place. So this is where the role of semantics comes in. फिर words के बाद आता है syllables and phonetics. वो मैं I'll not go into the details. I'll just let you know कि सबसे पहले जो across all languages, you know, it may be Hindi, English, Latin, French or German, all languages, उसको जब आप divide करते हो तो उसका जो letters हैं, they're made up of two components. One is consonants and one is vowels. संस्कृत has the most evolved system of letter, क्योंकि उसमें शायद 23 vowels हैं and remaining 64 total letters हैं, और remaining जो है उसके जो वो consonants है. Now vowels जो है when you right from day zero जो है, vowels start early to appear and consonants start they basically take the shape in later life. Because vowels को voicing के लिए जो है you need to take help of simple mechanistics. Consonants को voicing के लिए you need to have complex mechanistics. ठीक है? Now this is very important. और फिर दूसरी चीज, क्योंकि vowels को बोलने के लिए केवल movement of the lips काम आते हैं, और consonants को बोलने के लिए you need more complex muscular machinery. और vowels को भी वो I'm sorry, consonants को भी जो है उसको segregate किया हुआ है, fricatives, plosives. My students remember, I tend to forget. So now we started with this thing, और उसके बाद next please. Okay, now fractals and self-iterating mechanism. Now fractals की बात करेंगे. Next please. Next. This is the basic mechanism or basic model that we could envisage, or we could set forth. 2021 में हमने जो publish किया था इसको, और उसमें हमने ये कहा था कि ये self iterating fractals हैं. Fractals यहाँ पर हम कह रहे हैं event related synchrony and event related desynchrony. Event related desynchrony is when जब ED signals को हम जब acquire कर रहे हैं, तो ED signals में जो है, ED signals को हम जो divide करते हैं various wave forms में, theta, delta, alpha, gamma, और उसके तहत हम करते हैं, depending upon 0 to 4 hertz, 4 to 8 and 8 to 12, और 12 से 30 और 30 and above is gamma. तो इस basically range में उसको हम divide करते हैं ED signals को. Now various wave forms में जो है, now उसको जब हम assess करते हैं, तो अगर इन various neuronal pools, if they fire in synchrony ना, तब तो क्या होता है जब I hope they know about power spectral transformation. नहीं, frequency domain and non-linear domain नहीं. Oh.
Some of them we know, but not all.
अच्छा ठीक है, then I'll cut short. I'll just say कि anyway, So दो चीजें होती है, ERD and ERS, event related synchrony, is when the neurons are firing in phase, and the force or the power of amplitude, it increases. And event related synchrony is when the neurons are firing out of phase, and which leads to the amplitude getting being decreased, or the power of amplitude decreases on power of spectral density. That's taken, right? So two components hai, and these are two fractals. Now both these fractals, they self-iterate. Chaos to padha hai unka? Nahi padha hai. Anyway, so fractals and self-iterating mechanisms. And let them, somebody, if I'm able to infuse some interest. So,
the clouds are not circles,
have you heard of that? वो क्या था? You know, the flutter of the butterfly effect in New York.
Like cauliflower is
Mammoth changes, right. So that's what. So that's basically in essence part of chaos जो है. तो ये mechanism था self iterating का, जिसमें कि ERS and ERD. ERS is a phenomenon. कोई भी नया stimulus human mind को जब impinge करेगा, so the neurons they tend to fire in a patterned response, जिसको हम बोलते हैं event related synchrony. That is an increased amplitude. And if कोई stimulus, if it is a learned phenomenon, उसका जो response जो देगा जो neuronal pools. Remember, अब आज से 20 साल पहले हम बात करते थे ये लोब है ये. Now we talk about distributed neuronal pools or neural networks जिसको बोलते हैं, right? ANNJ. So neural networks की बात करते हैं हम. इसमें ERD and ERS. ERS is the phenomenon where is responsible for a novel phenomenon, and when the novel phenomenon becomes learned, then the response is converted from ERS to ERD. That is desynchrony. And ERD then becomes opens the gate or the portal for information to travel from A to B. So this was basically our model. Next, please. Okay. Human mind jo hai, wo, remember, it is working on the premise of both stimulatory mechanisms and inhibitory mechanisms. क्यों दोनों साथ साथ क्यों चलते हैं? So that the final response जो कि आप देख पा रहे हो, say for example you are picking a cup of glass and drinking it, so उसमें there are various other muscles also which needs to be inhibited, and there are muscles which need to be stimulated. Now ये दोनों चीजें, they need to work hand in glove. That's where mathematical modeling comes into play. That's how we model this thing. And then we said ki, okay, so the fractals हैं ERD or ERS ka, they self-iterate, and there is basically a mechanism of a central mechanism of ERS, that is theta ERS, which is important कि कोई भी stimulus को perceive करने के लिए the human mind needs to focus the attention onto that stimulus. Now focusing of attention is represented by the theta waveform, and that also the event related synchrony, that is there is an increase in amplitude in the theta wave. Why it happens, I don't know. I mean, you could let us know. The mathematical modeling could let us know why I mean, it could be more optimal for the neural environment, but this is what the patterning is which we came across. Next, please. Next, this is जो हमने बताया MS activation जो interfacial है, और last phase में जो activation of the variable paired muscle effector. Next, please. Next, please. Next, this we have done. So वो basically जो motor neuron system activation का जो है, that is इससे पहले वाली नहीं नहीं इसके बाद वाली जो म्यू रिम जो बोलते हैं, म्यू रिदम, which is ERD, event related desynchrony, which this is taking place in the alpha waveform of the EEG signal. Next, please. Next. Yes, next, please. So next, this was in a sense our final conclusion, where we said that the human mind working on the principles of chaos. It generates fractals of ERD and ERS, which tends to self-iterate. Okay. And other important feature is that we talk about neural networks. We don't talk about particular lobe or responsible for that function. We give way now. We talk of neural networks that have a tendency to crosstalk. Okay, crosstalk, but this tendency to crosstalk can happen, or flow of information can happen only when the phenomenon of ERD takes place. ERS jab tak there is a closed gate which is not letting in information to flow from A to B, because that is neurally viable and neurally compliant as well. Jab tak wo learning nahi hogi na, kyunki the human mind is functioning or is basically priming only on one premise or one tenet, that is memory formation. That's it. Thank you. This was in a sense our conclusion. That is the chaos of the cosmos is basically working, is a working principle of the human mind. Yes, next please. These are the references. मैथमेटिक्स से का जो है हमने एक तो मेरा पैशन भी है और मेरा वो fascination भी है. We took help of maths in COVID as well. We were trying to model, but unfortunately COVID eluded everyone's attempt. ARIMA model था, वो हमने कोशिश करा था trying to predict how it would tend. But another important feature about COVID that reminds me, you know, pandemics have a tendency to recur every 100 years. 1919 में आया था, 100 year पहले, and this is the, I think, the more characteristic feature of a crowd gatherer, which basically humans have become. जो पहले जो hunter gatherer की जो characteristic थी, उस समय pandemics नहीं हुआ करते थे. अब चूंकि ये crowd gatherer है, after 100 years it is coming. But you could let us know through modeling. दूसरी चीज mathematics का interface जो है, how it can help. Now, you know, there's an exotic example. If you remember the Hodgkin-Huxley model of how the human mind जो है ना, or the nervous system is working on the principle. It is basically an excitable made up of excitable tissue known as neurons. On neurons, they tend to generate impulses. Now, ये generation of impulses and propagation of this impulse. This was basically modeled by Hodgkin-Huxley of University of Cambridge. Sir, he would have enlightened us more. And can you imagine? They modeled and envisaged a program which was discovered 10 years from then. That is 62 or 63. They got the Nobel, and 74 it is X-ray crystallography say they could basically discover the various gates of sodium channels and potassium channels. So that I mean they could model that. But दूसरी application जो है AI and augmented medicine में है, और चौथी जो हमारा जो model जो बना था, it was based on basic principles of mathematics and nonlinear physics. Thank you very much. Thank you for your kind attention. Any questions, please? Any questions? Most welcome.
Sir, you had mentioned about some data related to various user disabilities. So
ADHD से ADHD में बेसिकली जो है वो ADHD ED शेड्यूल नाम एक्वायर किया था। ED शेड्यूल जब एक्वायर किया था हमने तो उसमें क्या था कि when the mirror neuron system is activated, so the activation of the mirror neuron system is represented by mu resolution. That is event directed D taking place on the EEG electrode with a place on the sensory motor cortex. I think am I audible at the back? नहीं डेटा थे चिल्ड्रन का था साहब ये आई थिंक it was 8 to 11 years के थे.
Yes, my question was like this: that if you find any application like this sort of thing can be done for kids of much lesser age, so that we can recognize such patterns in future that they are going to have such disability.
Good, very good. अच्छा ये हाँ this we left it. उसके applications क्या थे हमारा ये इस मॉडल का application अभी और आपको बताता हूँ मैं जो है अभी recently we had sent it. उसका जो ADHD का जो हमारा जो था जो डेटा था एंड जो डॉक्यूमेंटेशन था now we उसके तहत we basically we have designed a computer based evaluation test for children with ADHD, which basically is also documenting and diagnosing ADHD, its severity, and it also happens to be a therapeutic protocol as well. क्योंकि उसमें क्या है हम कोशिश कर रहे हैं मिरर न्यूरॉन्स की प्लास्टिसिटी को इंड्यूस करने की. तो जैसे जैसे उसके मिरर न्यूरॉन्स की प्लास्टिसिटी बढ़ेगी वैसे वैसे जो है उसका स्कोर अच्छा जाता जाएगा और उस पर जो कॉपीराइट भी हो गया मिल गया है हमारा हमको. दूसरी चीज जो मॉडल जो हमने करा था इसका एप्लीकेशन इज इन BCI और ब्रेन कंप्यूटर इंटरफेस. नाउ व्हाट हैपेंस इज in patients with refractory epilepsy which is not amenable to any treatment है ना. एक तो फिर उसके लिए दो चीजें होती है या तो फिर सर्जरी करें या फिर डीप ब्रेन स्टिमुलेशन होता है. यू इम्प्लांट अ स्टिमुलेटर in one of the deep structures of the brain और फिर वहां से जो है वो impulses generate करता है so that ये जो avalanche of spiking जो होती है ना neuronal spiking which leads to seizure activity वो कम कर दे. बट उसमें ऐसा एक इसके दो मॉडल्स हैं. एक तो ओपन लूप है और एक क्लोज लूप है. ओपन लूप तो जो है वो कंटिन्यूस जो है वो डिस्चार्ज करता रहता है. क्लोज लूप ये है कि जैसे ही वो उसको पता चला कि ये डिस्चार्ज होने वाला है उसके तहत वो ऐड करना था. क्योंकि कंटिन्यूस डिस्चार्ज में आप करोगे ना तो उसके साइड इफेक्ट्स आते हैं बिकॉज इट टेंड्स टू इन्फ्लुएंस मेमोरी एज वेल. मेमोरी ठीक है बिकॉज यू आर प्लेसिंग एन इलेक्ट्रोड place which is responsible for the basic premise of the human mind and that is memory. तो इसलिए जो closed loop system है that is a better way of this thing. तो ये it forms part of BCI brain computer interface जो है.
Any other question? So I think
is of this application this they identified this applications of mathematics applications I can explain here.
is there any book on that topic?
Okay.
Mathematics is always I have a short book.
So now let's thank Professor Amitabh Dubey for a nice interactive session with all of us.
It's a privilege for me to thank the Department of Mathematics and Department of Physics because their contribution has been exemplary and very instrumental for this model. We covered this model in 2021. So field trial testing the re hai uski jo hai wo अच्छा होगी.
Nidhi?
Thank you so much, sir. Now, I would like to invite Professor Tilok Mathur, sir, to present certificate and memento to Professor Amitabh Dubey, sir.
Can you reproduce some of the data on let's see here so images. We talk after the session. I'm sorry, yeah, we are doing it. Thank you.
Thank you so much, sir. Thank you. Now for the next session, I would like to invite Professor Kailash Singh, sir. And to chair the session, I would like to invite Professor Shri Agrawal, ma'am.
Thank you. It's my privilege to announce the name Professor Kailash Singh for his next talk. And the title of the talk is Application of Optimization Technique Using MATLAB. And why I'm feeling so privileged, actually, sir, you are done BE from University of Roorkee, and I'm also done my MSc from University in 1998. So that's good for me. And you have done your MTech from IIT Kanpur and PhD from Curtin University of Technology, Australia in 2007. And your research interest is modeling and simulation, advanced process control. He has published more than 60 papers in national and international repute, and he's supervised more than 10 PhDs and 1935 citations. So, sir, please, that the title is Application of Optimization Techniques Using MATLAB. Thank you, sir.
Thanks a lot for the introduction. Basically, in my talk, I think this talk will be more useful to the research scholars who are working in various areas. And you know that optimization techniques is very useful, and it is a useful tool. And if you work in MATLAB, what are the various kinds of tools available and how can you program in MATLAB? So that may be very, very useful for the research scholars. Next slide, please. There are several application areas, and you will find in almost every discipline, there is use of optimization techniques like optimum design of industrial equipment and plants, finding the optimal trajectories of the space vehicles, design of civil engineering structures, design of pumps, turbines, and heat transfer equipment for the maximum efficiency, shortest route taken by the salesperson visiting various cities, design of optimum pipeline networks for process industries, optimum design of electrical machinery such as motors, generators, and transformers, optimum design of control system. This is a very short list, but still there is long list where you can apply the optimization techniques. Next slide, please. You know that the basic optimization problem is minimize some function. You are giving some objective function, and there are some constraints, equality constraints, inequality constraints. There are some lower bounds, upper bounds. There are some design variables. So how to use the optimization technique? Next slide, please. Optimization is divided into several parts: unconstrained optimizations, constraint optimization, single variable, multivariable. For the simple most, minimize function, then you have to have the necessary condition that the first derivative should be 0 and the second derivative should be greater than 0 for the minimization problem. Next slide, please. The simple most, we apply the Newton's method. The numerical techniques are very useful in MATLAB. The Newton's method, which works like this, that if you plot the derivative f dash versus x, then wherever it intersects this y-axis, it gives you the optimum point. So analytically you can find out, but it's sometimes when it is a long problem, it becomes very difficult to solve. So this is shown graphically that, and this is the equation which is representing the Newton's method, which is actually the iterative method. First to take some initial guess. So here k is representing some iteration number, xk plus 1 equal to xk minus the first derivative divided by second derivative. Next slide, please. We sometimes use finite difference approximation as well if we do not have the analytical solution of the first derivative and second derivative, then we can use simply center difference formula. Next slide, please. Just as an example, suppose this is a problem, a non-linear the function. You have to minimize this function, for example. So if you apply Newton's method or Newton's method with finite difference approximation, so how can we program in MATLAB? So that is one thing. Next slide, please. So what we do generally, we actually make some function. You can observe in the last 5 lines, this is a function which is defined as the objective function f. So how do we code f equal to x to the power 4 minus x plus 1? Okay. And then we also define the first derivative df equal to 4 into x to the power 3 minus 1, and then the second derivative 12 into x to the power 2. And our input argument is x and the output argument is f, df and d2f. So we use this function in our main function where you can see that the our output arguments are opt x, f and df, because we want to find out what is the optimum value of f. So what we do generally in the non-linear optimization problem, we take some initial guess. So just as an example, here we have taken the initial guess x0 equal to 1. Then the tolerance limit, we have to actually set this limit. If you want more accuracy, this tol x should be very, very less. And you can fix the maximum number of iterations. And then what you can do, you can display the iterations. So this is our for loop, for example. We want to use this for loop for the maximum number of iterations from 1 to max iter. We are actually calling this function. And we are actually using this Newton's method, xk plus 1 equal to xk minus df upon d2f. And then we are displaying the results. And then we are comparing whether our result has been converged or not. So we are comparing with the tolerance limit. And if it is converging, then we can break this for loop. And then we print the solution. So this is how our output comes out, like x equal to 0.629, f equal to 0.52, df by dx. It is coming out. So this is the solution we are finding out. Next slide, please. This is the Newton's method for using FD approximation. Sometimes we do not have the analytical solution of some derivatives or second derivatives. In that case, we can use the finite difference approximation. So here we are simply defining a function f equal to x to the power 4 minus x plus 1, and we are actually calculating the first order derivative and second order derivative using the center difference formula. And so we are calling this function again and again. Obviously, this this may have certain error if the value of h, which is the step size, if the value of h is large, then obviously the error will be large. So we can select the very less value of h so that we can get more accurate result. So the method is similar. to the simple Newton's method. The rest is same. Next slide, please. There is another method that is called quasi-Newton method. So again, here what we do, we select two arbitrary points in such a way that the value of first order derivative are of the opposite sign. One is positive and another is negative. So for example, here the points are P and Q, XP and XQ. So what we are doing, we are actually drawing a straight line joining these 2 points. And wherever it intersects the y-axis, this is the approximate guess of the optimal solution. But again, in the next station, we can improve the solution. So this is the technique. This is the formula which we are using. X bar equal to SQ minus first order derivative at the point XQ divided by the value of M, which is nothing but the slope of that straight line. Next slide. This is another method, which is quadratic interpolation method. And in this case, we actually approximate our objective function by a quadratic polynomial. So if we differentiate this function, then f dash will be equal to 0, and therefore the optimal point should be x star equal to nothing but minus b upon 2c. And the value of b and c, how to find out? We actually choose 3 points, and we use these 3 equations to solve for a, b, and c. So the last equation which has been written, this is nothing but equal to minus 1 upon 2 b upon c. So what we do, actually we choose 3 points, and we keep on improving upon the optimal point successively, iteration by iteration. Next slide. So this is how we actually keep on improving. So if our x1, x2, and x3, these are our initial gas values, and if our first optimum point is coming out between x2 and x3, then we can see from this figure 1a that our optimal solution is lying between x2 and x3, and x1 we can reject. However, in the second case 1b, what we can do, we can reject our point x3. And this is how we can keep on improving. So every case has been displayed here, how to reject the point. Next slide. Sometimes you research scholars might be using the least square method. So just as an example, if this is a quadratic polynomial and you want to fit this quadratic polynomial to certain experimental data, you have been given the experimental data of x and y. So y equal to beta 1 plus beta 2x plus beta 3 x square, let us say. So in general, we can represent y as a linear function of xj. So y equal to summation beta j xj. And what we do, we generally minimize the sum of square residuals. So this is what we are doing, and then we can optimize. You can use optimization technique to minimize this function and find out the optimum values of the parameters beta 1, beta 2, and so on. Next slide, please. So this is how, if we find out analytically, we find that the optimum values of the parameters beta is equal to x transpose into x whole inverse into x transpose into y, where x is just a matrix of the experimental data, you can see, and y is the output data. Next slide. So just as an example, you have the data of x and y, and you want to fit a quadratic model. So what we do, we have programmed in MATLAB. So we are defining the function. Here the data x and y have been defined in the tabular form. And what we are doing, x, which is nothing but, as I showed in the previous slide, x is nothing but a matrix which we are defining here. And then beta, we are simply finding out by placing the formula inverse of x transpose into x multiplied by x transpose into y. And then we are finding out the predicted value of y by using simply this equation, and then we can plot and we can find out how our predicted values are being fitted here over the experimental data. So this is what we can find out by using the plot. Next slide. Similarly, unconstrained multivariable optimization, the necessary condition is that our first order derivative should be equal to 0. Next slide. There is method which is called steepest descent method. In this method, actually, what we do, we find out the direction in which our function will be minimizing. So this is based upon the first order derivatives. Okay, so we calculate this first such vector s equal to minus gradient of f, and then we use simply a relation xk plus 1 equal to xk plus alpha k sk, where alpha is actually the step length, s is here the direction. So the step length alpha k, what we do, we actually do the line search method, and we can find out the value of alpha in the most optimal way. And then we keep on iterating the procedure until the convergence. Next slide, please. Conjugate gradient method. This is another method in which actually the first such direction is s equal to minus of the gradient of f, and then we find out the first iterative value of x1, and here alpha naught, again this is by using the line search procedure, and we calculate the value of f at the new value of x1, and then the new search direction is somewhat different than the steepest descent method. So this is the formula which we use in the conjugate gradient method. Next slide, please. So for every iteration, we keep on doing this procedure until the convergence. Here, the value of alpha, which is by using the line search procedure, we can easily find out mathematically that the optimal value of alpha comes out to be minus of gradient of f multiplied by s divided by s into Hessian matrix into s. H, which is the Hessian matrix, which is actually the matrix of the second order derivatives. And we can terminate the algorithm when the norms of the gradient of f is less than some prescribed tolerance. Next slide, please. So this is how we can program in MATLAB. We use the Hessian matrix, as well as we use the first order derivative and the function value you can see in the function, and then we are calling in the main program, and we are finding out the value of s, and then alpha, and then the new value of x, and then we keep on repeating the procedure until either the maximum number of iterations have passed or until the convergence. Next, please. This is the program for Fletcher-Reeves method. It is again similar to that. The only difference is in finding the direction, and the iterations are similar to the steeper descent method. Next. Similarly, Newton's method can also be applied for the multivariable optimization technique. So here again, the use of Hessian matrix is there. Delta x is equal to minus of Hessian matrix inverse into the gradient of f. So this is just an example in which the objective function is f equal to 4x1 square plus x2 square minus 2x1 x2, starting at the initial guess x not equal to 1, 1. We can choose any guess value, and what it will do, it will actually try to optimize around this guess value. Next slide. And the first order derivative, that is the gradient, how to find out, it is nothing but del f by del x1 and del f by del x2. So this is nothing but a vector, and the Hessian matrix, this is a matrix of the second order derivative, and we can find out the inverse of this matrix, and then we can find out the delta x which is equal to minus H inverse into delta F. So again, this is nothing but a vector. And therefore, the solution we have found actually only in one iteration, because this is nothing but it is a quadratic objective function. That is why we found the solution only in one iteration. Otherwise, it may take more iterations. Next slide. Leeuwenberg-Marquardt method. In this method, actually, this is similar to the Newton's method, but here what we are doing, we are actually forcing our Hessian matrix to be positive definite. So what we do, we actually choose an initial estimate of the value of a parameter beta naught, which is very large, around 1000, and then calculate the first order derivative gradient. And then we find out whether our gradient is less than the prescribed tolerance limit or not. And then we solve H plus beta I into S equal to minus the gradient of F. And then we solve for xk. Next slide. So this is how we can find out if our multiplication of gradient of F and the search vector is less than 0, then we can go to step 8 and choose the value of alpha by the line search procedure. If this is not the case, then what we can do, we can increase the value of beta. Next slide, please. Just example of Newton's method and Leeuwenberg-Marquardt method. Here it is nothing but a non-linear objective function. So how to minimize it? Next slide, please. So this is using the Newton's method. Here, what we have done, we have found the derivative, that is gradient, and then the Hessian matrix using the function. And then we are repeating the iterative procedure. So we are finding the value of x nu by the equation x minus inverse of h into df, and keep on repeating this procedure until the convergence. Next slide. In the Leeuwenberg-Marquardt method, again, this is similar to that, but the only difference is that we are actually adding the value of beta I to the Hessian matrix. And then we are going on repeating the procedure until the convergence. So this is how we can solve it. Next slide, please. There are some inbuilt MATLAB functions as well for solving the optimization problems. Next slide, please. For example, this is the unconstrained minimization problem, and you want to minimize it. So you can use directly some inbuilt function, which is fmin unc, that is used for unconstrained optimization problem, fmin unc. So how to use it? Next slide. This is the objective function we have to define in MATLAB program. Function f equal to obj fun in bracket x. X is the input argument, f is the output argument, and we are defining the objective function. And in the command window, what we can do, we can take the initial guess value x naught equal to -1 and 1. You can take any guess value, and this is the syntax of using fmin unc. So xmin f eval equal to fmin unc in bracket at the rate of obj fun x naught. Obj fun is nothing but the function name which you are using in the above file, and x naught here it is the initial guess. So it will give you the result like the minimum value of x and what the value of f at that value of x. So it is coming out to be 0.5 and -1 in this particular case, and the value of f is coming out to be very, very less. And you can just means it is very, very small value, and so it means it has converged. Next slide, please. You can also use the constant optimization problem. That there is an inbuilt function which is fmin_con. Fmin_con is used for solving the constant minimization problem. So here there are certain constraints. The constraint may be linear, non-linear. They may be bounds, lower bounds, upper bounds. So this is just a problem in which there are constraints. Two constraints are there. Okay. You should write the constraint in such a way that the inequality sign should be less than or equal to. So convert into this form. Next slide. So this is a program which has been written. The name of the program is const.m, a function file here. And we are defining the objective function in the function name obj_fun. And we are actually defining the constraints also in a function name const_fun_c. So these constraints have been defined in the form of C1 and C2 here, you can see, and there is no equality constraint. So it is actually empty. And we are calling this obj_fun and const_fun here in the main program using the inbuilt function fmin_con. This is very, very useful program. In this fmin_con, you can actually have any equality or inequality constraints, or they may be linear constraints, they may be non-linear constraints, lower bounds, upper bounds, so whatever. So that is very useful inbuilt function in MATLAB, which you can use. Next, please. Linear programming, also you can program very easily in MATLAB. There are certain inbuilt programs like linproc. This is the name of the inbuilt function. The syntax is that you have to use the function in the simple vector form. Here f vector is nothing but -5, -4, -6. And the constraints are, these are the linear constraints. And there are lower bounds here, you can see in this example. Yes. Okay. Okay, so I think time is going to be finished. So, okay, let me conclude it. So we have actually seen that how to use the inbuilt functions, linproc, fmin, unc, and how to code it in MATLAB. So if you have any question till now, you can ask me. Right? I think it is almost finished. Yeah. If you have any question, you can ask me.
Thank you, sir. Thank you. It is a very informative lecture, actually, who is working in the optimization, so many inbuilt function as well as the M files they're providing. And if you have any questions related to this, you can discuss with sir. You can take the mail ID and you can discuss with him about the optimization functions, which we can use in a MATLAB, basically. Thank you, sir. Thank you for your information.
I request Shivi Agrawal ma'am to present memento and certificate to Kailash sir. Thank you so much, sir. Thank you so much, ma'am. Now it's a lunch break and we have 30 minutes for the lunch. So we will resume here sharply after 30 minutes. So all the participants, I